Plug in the power cord before turning on. Each plug can prevent errors and won't be wrong, but be careful not to force it in. Connect the power cord to the inside of the case. Connect the power and coding wires to the back of the robot. There are some yellow connectors when the robot is out. All of them must be removed before using the robot. Otherwise, it may cause damage to the reducer. Turn on the power and wait for the start up. The power indicator light turns on to indicate power. The right side is the emergency stop button. In case of emergency, you can force the robot to stop. Then activate the emergency stop and laser buttons in sequence. After turning on, wait for the driver to enter the programming interface. The screen will display the last used program. The key has 3 gears. The manual gear is for programming. The display shows a palm. Automatic mode is for production. It shows a circular arrow. You can use the test driver to start the program. Remote gear is for production. It is operated through the host computer or workstation. Let the robot start running. This is the emergency stop button. Press it in case of emergency. After pressing, it will alarm. Turn it clockwise to lift it up to clear the alarm. 4 volts power is in off state. The robot cannot start. Turn it on. In remote and automatic mode, the robot can run. If you want to move the robot manually, you need to press the safety lock on the back. There are 2 coordinate modes for the mobile robot. The joint coordinate is on the right side of the screen. 6 axis from J1 to J6 will appear. Move the 6 axis by pressing the buttons to make the axis rotate forward or reverse. In programming, the rectangular coordinate is generally used. Press the hand pressure. The right side corresponds to the X, Y, Z, A, B, C rectangular coordinates. Move the end of the robot through the buttons. V up and V down can adjust the running speed of the robot. Here shows the current speed. If the robot is locked, you can click these 2 positions. Can break the locked state. Here are the coordinate shortcuts to switch the coordinate system. Clear alarm button. It can clear complex alarms like arc interruptions. Here are the run and pause buttons. This is the coordinates of the working 0 position. Here shows the running mode. It shows single step now. It means only the first line of programs from 1 to 10 is running. You need to click Run again to execute the next line. Click to switch to single shot. It means running all programs from line 1 to 10 once. The last one is infinite loop. It's displayed as double arrows. It means after running all 10 lines of programs, run all programs again. It is suitable for situations that require repeated welding. Generally, we use the single cycle mode after the robot arrives. Remove the yellow connecting key. Then you can move the robot. Press the safety lock. Use the joint or rectangular coordinates. Move machine shafts away from each other. And move them apart a little. Then use the button of the working 0 position to return to 0. At this time, the scales of each axis will align, except for the 5th axis, because the robot is at the 0 position. Next, move each axis of the robot. Machine brake. Press the 1 axis button, and then press the safety lock on the back. This is 1 axis. It's 1 axis from the bottom. 1 axis positive, 1 axis negative. Negative 2 axis. 2nd axis positive. 3 axis negative. 3-axis positive, 4-axis negative, 4th axis positive, 5-axis negative, 5-axis positive, 6th axis negative, 6th axis positive. We just moved the joint coordinates. Next, adjust the rectangular coordinates. Press the hand pressure. Here becomes XYZ ABC, represents the end of the joint welding torch. It moves forward or backward when moving. Y represents the left or right movement of the torch. Z-axis means up or down movement. ABC is the rotating attitude of the welding torch. Let's start writing a program now. Create a new program. Enter a name. Here we name it 12,345. Open is a blank program. The robot's operation first needs to write its starting point. We need to hold the hand pressure. This is MJ. MJ is articulation, and getting from point A to point B could be any trajectory. The trajectory is uncontrollable. Generally, when in the air, the speed will be faster with this instruction. In the formal welding process, we usually use straight or joint instructions. A straight line represents directly from point A to point B, is the only straight line. MC command is used to weld circular arcs. 3 MCs can form an arc. A complete circle requires at least 6 MC commands. AS is arcing. A is to extinguish the arc. WS is swinging arc start. W is the end of the pendulum arc. This column is the shortcut key for the instructions. There are more functions here. Let's create a new welding program for the robot. Move the robot to the welding starting point. Press the hand pressure, and you will hear a click. Use MJ to write the current position. V represents speed. 100% means fast speed. Smoothness represents the smoothness of the welding action. 0 may have a pause. 100 makes the movement smoother, but the trajectory will not reach the exact point. T represents tool number 1. Then press D to accelerate. Slow down and don't move. Avoid problems. OK represents that this position has been written. Next, the robot will reach the starting point of welding. Use ML instructions to go straight to the position of the welding starting point. The unit here is millimeters per second. It represents the speed of the welding head at 100 millimeters per second. The speed will be affected by the magnification. Arc welding requires the use of the S instructions. Writing an S instruction represents an arc, which includes the welding process and parameters. To start welding a straight line, the robot needs to be moved to the target position and then write the target ML position. Here, you need to set the welding speed. It is recommended to set it according to actual use. This time we set it to 10 millimeters per second. It will be accurate to the point. Next, we need to weld an arc. After moving the welding head to the arc welding starting point, using the MC instructions for microspeed, with the unit still being millimeters per second, the value of 10 square bytes needs to be set to 100. Otherwise, the arc will not be round enough. The number of MCS must be an even number when writing the MC instruction value again. Just copy it directly. End welding. Enter the AES instructions to end the welding. Finally, raise the robot. Write the MJ instructions. In this way, a small section of the line is welded. After reaching the welding point, start welding. Add a light emitting instruction. Add an output light command. Select the third auxiliary instruction. Then select DOS. Numerical output selection D019. If the light output command value is 1, it is turned on. At the end of welding, we need to turn off the laser. Select Do to change to 0. It will be added to the program. Here represents welding starts from 8 to the 9th segment. The other programs below, the robot will not weld. For manual debugging, light needs to be on. You can click here. There are shortcuts here. Click Switch to switch the switch. Once the robot has finished running, click Stop running. Turn off the motor. Turn off the rack power. Then turn off the laser and the emergency stop button in sequence.